So today I'm very excited to share with you some of our recent work and
Can you use a microphone, please?
Can you hear me now?
Yeah.
All right, great. So I'm very excited to share with you some of our recent work looking at the role of the blood-brain barrier in Alzheimer's disease and some details about an upcoming project that we have just started. Okay, so by now you're all very well aware that Alzheimer's disease is a neurodegenerative disease characterized by the accumulation of pathological proteins, which ultimately leads to neurodegeneration and cognitive decline. However, what we've recently become to appreciate is that Alzheimer's disease is really multifactorial, with various factors, various mechanisms contributing to its progression, including things like inflammation, vascular dysfunction, and metabolic dysfunction. And over the last several years, research has identified several important factors that can influence these pathways, including certain factors that are not modifiable, such as your age, your sex, your genetics, and then other factors that are potentially modifiable, like your health factors, your lifestyle, your environment. And we know that the brain is not an island, although many people like to think of the brain as this, separate entity. It's intimately connected with the systemic health. And we now understand that one of the ways our periphery communicates with the brain and may contribute to brain disease is via something called the blood-brain barrier. So the blood-brain barrier is a semi-permeable interface between the blood vessels and the brain tissue. Now, the blood-brain barrier regulates the signaling and transport of molecules from the systemic circulation into the brain tissue. A healthy blood-brain barrier can protect the brain against toxins and other things that can be detrimental to the brain, whereas blood-brain barrier damage can impair brain function. Okay, so there are various ways we can measure blood-brain barrier permeability. One of the most sensitive and direct ways of measuring it is using an MRI technique. It's called dynamic contrast enhanced MRI. And in this technique, we ingest a gadolinium-based contrast agent, and then we can measure how much of that contrast leaks from the circulation into the brain tissue. And so from studies over the past several years, we've learned that indeed the blood-brain barrier becomes leaky in Alzheimer's disease. But there are many things we still don't understand about the role of the blood-brain barrier in Alzheimer's disease. In particular, how early along the Alzheimer's disease course does it become dysfunctional? Is it actually playing a causal role in the development or progression of Alzheimer's disease? And finally, what factors can contribute to blood-brain barrier breakdown? And so these are some of the questions that our lab is trying to address. And I would like to just walk you through a little bit of data from an ongoing study that we've had going on for the last few years, and you've all seen this figure here, so I don't need to walk you through it. But the first aim of our study is to determine if the blood-brain barrier becomes more permeable or dysfunctional in this kind of prodromal stage when individuals are developing mild cognitive impairments. Now, our second aim is to look a little bit earlier in the disease course and to see if the blood-brain barrier becomes dysfunctional in asymptomatic or cognitively normal individuals who are at elevated genetic risk for Alzheimer's disease. And then finally, the third aim of our study is to determine if blood-brain barrier leakage is associated with signs of neurodegeneration. So the study is still ongoing. We're still collecting data, so if anyone's interested in participating, we're enrolling. But I wanted to share just a sneak peek of some of our preliminary findings. So far we've enrolled 47 participants of the ADRC longitudinal study, including 35 who are cognitively normal and 12 with mild cognitive impairment. And these individuals underwent that dynamic contrast enhanced MRI scan I told you about earlier. So walking you through some of the preliminary findings for our 3 aims, we first found that blood-brain barrier leakage, plotted here on the y-axis, was greater for individuals with mild cognitive impairment compared to those who were cognitively normal. And interestingly, this was found in a region of the brain called the entorhinal cortex, which is one of the earliest targets of Alzheimer's disease neuropathology and neurodegeneration. So next we looked a little bit earlier in the disease course, and we focused on cognitively normal individuals and categorized them as people who carried or did not carry that ApoE4 gene. That's a risk factor for Alzheimer's disease. And we found that cognitively normal ApoE4 carriers also showed increased blood-brain barrier permeability in the white matter, or the structural connections of the brain. Finally, we again separated participants into those with and without that ApoE4 gene, and we found that ApoE4 carriers demonstrated a correlation between higher blood-brain barrier leakage and a marker of microstructural abnormalities. So this is, we believe, an index of neurodegeneration. So to summarize our preliminary findings, we found that the blood-brain barrier becomes leaky not only in individuals who are developing mild cognitive problems, but also in cognitively normal asymptomatic individuals who are at increased risk for developing Alzheimer's disease. And interestingly, we also found that blood-brain barrier dysfunction is associated with microstructural brain injury only in individuals who are at higher genetic risk for Alzheimer's disease, suggesting that blood-brain barrier breakdown might be related to early neurodegenerative changes. So together, these findings supported our hypothesis that the blood-brain barrier lies at this interface between all of these kind of systemic risk factors and some of the brain changes that occur in Alzheimer's disease. And with the advent of the COVID-19 pandemic, we decided to focus on this particular risk factor here, which is pathogens. So things like viruses we know can have been associated with Alzheimer's disease. So just for a little bit of background, like I just said, viral infection has been linked to risk for Alzheimer's disease. A large proportion of COVID-19 patients experience cognitive impairment even months after their infection. The ApoE4 gene has been linked to worse outcomes following COVID-19, and COVID-19 severity has also been linked to biomarkers of amyloid and tau pathology as well as neurodegeneration. And notably, the blood-brain barrier carries the receptor to which the SARS-CoV-2 virus binds. So together, all of these findings prompted our hypothesis that COVID-19 could promote cognitive decline and neurodegeneration via blood-brain barrier dysfunction, and that this pathway could be compounded by Alzheimer's disease risk. So we just recently started this study. So to walk you through the goals of our study, first we want to determine if older adults with long COVID, particularly with cognitive complaints, show blood-brain barrier breakdown, cognitive decline, and neurodegeneration. We also want to examine whether COVID-19 interacts with Alzheimer's disease risk to accelerate cognitive decline or brain injury, and if women who are at greater risk for Alzheimer's disease are more susceptible to the effects of COVID-19 on brain and cognitive outcomes. So we are actively enrolling, and we are looking for people who are age 55 and older and either had a prior COVID-19 infection and are experiencing persistent cognitive complaints, or we're also looking for controls who did not have a severe COVID-19 infection and are not experiencing COVID-related cognitive complaints. The study involves 2 visits to UCSD within 6 weeks of one another, First visit involves consenting, a blood draw, and then cognitive testing only for people who aren't participating in the ADRC longitudinal study. And then the second visit involves a 45-minute MRI with contrast, providing a saliva sample, and then completing a questionnaire. And we compensate with a $100 Visa gift card. So I'm over time. So with that, I just want to thank everyone who have participated in our prior studies. So thanks to all of you, particularly those who may have contributed to these data, acknowledge our funding sources, and then our lab members and collaborators.